So what I'm going to have you guys do at your tables is I'm going to give you guys a little bit of time, and you could do it on your table or you can do it on the wall and all kind of gather around. But I want you to just spend a couple of minutes thinking about and talking about what is algebraic thinking. When we present algebra to students as a set of procedures, what's very difficult for students to do is look at a situation or read a situation in a problem and come up with an algebraic equation that represents that situation and use that equation to solve. And the reason why is because there are lots of different equations that you can often set up, and it requires a moment of creativity. There's a certain playfulness to algebra.
I think it's not just seeing patterns, but actually developing patterns that'll predict. You know,
it's seeing structure, seeing patterns, and then seeing how they can be altered.
Or played with.
Play with.
Yeah, I like the word.
And introducing algebra in this way comes from the idea that algebra is not a set of procedures. Algebra is more than X. What algebra is a way of thinking. So excellent work on these. We're going to come back to them. That's why I had you put your names on them, because maybe today, maybe tomorrow. But now I'm going to have you guys work on a problem. One way that I like to introduce algebra is using a pattern that's a picture. One I really like is the arch problem. The first question that students work on is, given these three figures, look at them and try to understand how they're changing such that you can draw the next two figures, the fourth and the fifth figure. Because what's important in this activity is students having to describe things. Having to describe patterns, having to describe pictures, having to describe. So you're going to be the hand. Excuse me, I'm going to be the hand. You're going to be the brain. Raise your hand if you can tell me how to draw figure 4. And what's interesting, you know, students can do it, but they do it in different ways, right? They're different things that they recognize, different patterns that they see that they use. Some are only looking at the number of boxes on the side. Some may look at the total number of boxes on the top. 3, and then 5 more on each side. There are different ways to visualize it. So the next step is to take the information that you have just for those first 5 figures and put them on a chart. The idea of the chart is to be able to look for patterns in a different way. I asked you to pick a chart. What are the categories in my chart?
Figure, number, square.
So from there, the next question is, what does the 10th figure look like? What that question does is it allows some people to take a big leap. Because what some people will do is they'll look at the chart and they'll notice, oh, well, every time it's another figure, this many squares are added, and so they already have the first 5, so they can continue that pattern for the next 10.
So put a middle square up, your center square.
Center square.
You put one on each side. And now you know that the figure, 10th figure, so you already done 5. They're going up by 2s. Mm-hmm. So you know that your 6th figure would have 15. Your 7th would have 17. 8 would have 19. And 9 would have 20. And then, 21, sorry, my fault. Mm-hmm. And then 10 would have 23. Now we have more information, so now the question becomes it's a little bit different. Not just describe what describe what the 10th figure would look like, but describe what in the 10th figure, which has 23 squares, what those 23 squares look like, how they're arranged. So then they look back at the first 3 and the first 5. Oh, okay, well, they're always 3 across the top. So if they're 23, then they're always going to be 3 there. And then 10 going down and 10 going down. So then you look back and you say, well, the 5th figure, 1, 2, 3, 4, 5, 1, 2, oh, that's the same. And then they've recognized another pattern. Is that true? The number of blocks in each column is equal to the figure number?
Below the first.
Yeah, I'm sorry. So if we put 3 across the top, is the number of blocks in each column equal to the figure number?
Right, yeah.
The next question is explain how you would figure out how many squares are in the 99th figure. So students who, when they were working on the 10th figure, are going to say, oh, well, if it's the 99th figure, there's going to be 100 down one side and 100 down the other side, and then 1 in the middle. Talk to me now about the 99th figure.
So I would add 1 to 99 to get the 2 vertical rows, to get a vertical row, and then double that. So that would be 100, double. And then I need so that becomes 200 for the 2 verticals, and then I just need to add the 1 in the middle.
Good. Someone else want to take a different crack? Someone else solve it in a different way? Some might say, oh, well, it's going to have 99 on one side and 99 on the other side and 3 across the top. So 3 across the top, and then now describe to me the arms.
I said each arm has the same number of squares as the figure number.
Each arm has the same number of squares as the figure number. Raise your hand if you agree with that. Keep your hands up if you agree with it.
You mean after the 3 across?
Yeah.
After
Yeah.
the 3 across the top? Along the tabletop.
After the 3 across the top. Okay, so that's the number of squares in the arms, but then you have to add the 3 that are on the top. So the last step would be to add 198 plus 3.
So there's different ways, but it's about, again, getting them to think about how can they use the information to make a prediction about what would follow. And then the final question is, in a few sentences, write a way to describe how to find how many squares would be in any figure. So 46, let's do 46. For some reason, I kept throwing out that number to various people. So if I want to know for the 46th figure, for the 46th figure.
Yeah, 46 plus 46 plus 3 for the bridge at the top.
You can look at the different ways of expressing a generalized statement, either 46 times 2 plus 3, or 47 times 2 plus 1, and look at whichever ones come up. You start building this real appreciation for students of oh, algebra does make sense. Often the way we present algebra is as this new thing, as if it's different from everything you've done before. And so this activity is about introducing algebra in a way that undercuts that idea and to show that algebra does connect to a lot of the things that they can do.